Hey folks, I wanted to put together a quick video on one of the most exciting new features we've got in NetBox version 3.3 that was released just a couple weeks ago in August. That is multi-object cable termination. So for a long time, a common pain point among NetBox users has been the limitation of only being able to attach either end of a cable to one termination point. So whether that's an interface or a pass-through port or a console port or what have you, you can only have one on either end. That's no longer the case in NetBox version 3.3. We put a lot of work into this to support multiple terminations for either end of a cable, and that allows us to better model things like multi-strand fiber cables and breakout cables. So I'll go through some examples here to show you how that works today. So I've got a really simple demo set up here. We've got two switches, just 1U, I think 48 port switches on either end of a path. And we've got two patch panels in between them. So these are 48 strand patch panels. So you've got basically one rear port, and that's a splice representing the fixed cabling between the two panels. And then on the front side of either panel, you've just got 48 individual SC fiber terminations. So that's one strand per port, 48 ports total, all aggregated to that rear splice between the two panels. So it's a mirror image. So we're going to be going from switch 1 to panel 1, following that fixed cabling to panel 2, on the back of panel 2, coming out the front of panel 2 into switch 2. So to start, I'm going to go to switch 1, and I'm going to just connect up its first interface here, gig 000. And I'm going to attach that to two front ports on panel 1. So I'm going to find panel 1, and then I get my selection of our front ports, nothing different so far, but you'll notice that I now can select two ports. Let's go ahead and give that a color just so it looks nice when we go to look at the trace later. Say create. And now we'll see that we've got the interface is connected to cable number 140. That's what I just created. And it's got two link peers now. So it's port 1 and port 2 both on panel 1. You'll notice that we see panel 1 here twice because we can actually connect it to different termination points on different devices as well, but that's not part of this demo. So now we have to do the same thing on the other side at switch 2. So I'm going to go to, again, I'm just going to pick the first interface here. And I'm going to connect it to the two front ports on panel 2 on the other side. Port 1 and port 2. And again, we'll give it a color. Okay. Now you see the same thing here. I've got the link peers. Now I also have a connection. So NetBox is now showing me the end-to-end connection from the local interface to the remote interface on switch 1 via those three cables. We can see the same thing on the other side on switch 1 if we just refresh that list. Now I'm going to trace from switch 1, gig 00 that we just connected, and we'll see the entire path now. So starting up here at the top, we've got switch 1 in the interface. You'll see that the cable now splits out. So it's literally showing you two different cables splitting out from the one. And those are going into the front ports 1 and 2 on panel 1, which then get mapped to, so internal to that patch panel device, we still have that same mapping of multiple front ports into a single rear port. So this is very typical in the real world where you have some kind of fiber trunk, typically it's some multiple of 12, that will break out into individual strands on the front. But still are all contained into one trunk cable, between panels typically. So we see that go to the cable, and then we've got the mirror when it hits the panel 2 on the rear side, splits out into those individual front ports, and then consolidates to that single patch cable. So from the two SC ports, each representing a single fiber strand, into the transmit and receive pair connected to the interface on the switch. So that's one great example, one very common example of how multi-termination cabling can better model what we do in the real world. So let's also look at the breakout cable example that I mentioned. So down here on switch 1, let's go to the second page. We've also got a few 40 gig ports. So a very common example of a breakout cable is where you've got a 40 gig interface on one switch that's being configured to be channelized as 4 independent 10 gig interfaces. And that is actually how 40 gig Ethernet works, or at least this particular flavor. There might be other things out there. I haven't, unfortunately, been able to keep up with everything lately. But typically, you'll have 4 physical 10 gig channels there that are each riding a separate physical media. So you've actually got Typically you use like an MPO cable that has 12 strands in it, 8 of which are being used, 4 for transmit and 4 for receive. So let's see what that looks like. Let's connect ET010 on switch 1. And let's say we have a breakout cable that's going to go to 4 individual 10 gig ports, or excuse me, interfaces on switch 2. So let's go, we're going to choose interface, because this time we're bypassing the panels entirely. We're just going to go straight to switch 2. Because this is a demo, obviously it's not something you'd really probably do in the real world. And then we find switch 2. And let's just pick the next available interfaces. So 1, 2, 3, and 4. And I don't know what color breakout cables are normally. Probably black, but we'll just use gray. All right, so we'll create that. And then we go down to our second page here. All right, we see ET010. And so now we've got our local peers, or link peers, end connection happen to be the same because there are no intermediary cables there. This is a direct connection, but you see that we're going from interface 010 to the 4 individual interfaces. And if we go to switch 2 now and refresh that list, we see the 4 individual interfaces connected, each going to ET010 on switch 1. So we can trace this out, and we see how that's split up. So we've got switch 1, the single 40 gig interface, and this is representing the 4 discrete 10 gig channels being broken out of that 40 gig interface. So that breakout cable or octopus cable or whatever you want to call it, going to those individual interfaces. We could do that across multiple devices as well, as I mentioned. Although that does get a little bit hairy when you're actually trying to show the diagram, because there's only so much information we can squeeze in there. But this is hopefully conveys the idea. We can trace in the reverse direction as well, and you'll only see, you'll see the same thing of all the 410, even though I traced from the one interface here, I'm going from gig 001, we'll see all of the connected local interfaces because they're all part of that same path. So that's NetBox version 3.3. It's available right now. I think we're actually going to push out 3.3.2 probably the same day I'm recording this. So it's out there, it's working. If you want to check it out, there's also demo.netbox.dev. That's open for public use as well. And I'll probably be doing a few more of these videos on some of the other features we've got. So keep an eye out for those, and see you next time.